Hi, everyone, and welcome to our presentation on the linear thin film applicator cleaning process, a project developed for Imagine RIT by L3Harris that we will be doing for our multiple disciplinary senior design. I'm Kyria Linda, and I worked on this as the project manager alongside my teammates Matthew Martin, Fletcher Salo, and Abdullah Spa. Here's a quick overview of what we'll be covering today. We'll start by introducing ourselves, then dive into the problem we were facing, our vision for a solution, the process we developed, and the expected outcomes. We'll also share a tricky challenge we faced, go over the budget, and finish with our acknowledgements. So, who we are. Our team brings together diverse skills from engineering disciplines. I'm Kyria, an industrial engineering student and the project manager. Abdullah is the mechanical engineer who focused on the technical engineering aspect. Matthew, our electrical engineer, handled communications and documentation. And Fletcher, another mechanical engineer, was in charge of purchasing materials and managing logistics with our budget. So what exactly are we working on? At L3Harris, there is a glue placement tool that applies adhesive to PCBs during the surface mount technology process. The issue is that cleaning this tool has always been a manual and inefficient process. Operators currently use ProClean solvent and wipes, but if glue isn't removed properly, it hardens and becomes much harder to clean, leading to downtime and performance issues within the machine. Our goal was to develop a consistent and effective cleaning process that keeps the glue performance at its best, while also limiting the operator's interaction to no more than 20 minutes. We also have to keep safety in mind. Any chemicals used had to be approved by environmental health and safety, and PPE was limited to gloves and safety glasses, nothing more intense than what they currently use. So here is just some of the components that we were cleaning. As you can see, they're pretty dirty. On the top left, we have our glue plate. On the right, we have our reservoir where the glue is held. And then on the bottom, we have a glue spacer that kind of just sits in there. So as you can see, these parts are pretty messy with the glue. So that's kind of what we're trying to avoid. This is over time, a lot of the glue sitting there, caked on, drying. So these were pretty dirty parts that had been dirty for a while. So, the end state vision. In our ideal future state, the cleaning process would be simple and intuitive for operators, safe, requiring only gloves and goggles, efficient, taking 20 minutes or less, and capable of running on its own once it's been initiated. We also considered integrating new equipment if needed, but with the goal of keeping things user-friendly and compliant with EHS guidelines. So here's what our proposed process looks like step by step. So we have two things that we're really looking to clean. We have nozzles from the machine, which we can't show, but that is another object that we need to be cleaning. And then we have the parts from the machine, as I showed you in the slide 2 slides ago. So the top one happens by itself and the bottom one happens by itself, but it happens at the same station. So, for the top one, we're going to remove this parts from the machine. And then we are going to use alcohol wipes to manually remove bulk glue from the large surfaces. Any of that tackiness, getting that off there. Then we're going to use cotton swabs and cotton balls as necessary to clean the glue from the crevices and all the hard to reach areas. And then we're going to perform a finishing pass using alcohol wipes on large areas as necessary. And as with the cotton swabs and cotton balls, we were hoping to be pumping isopropyl alcohol into these things just to kind of get a little solution on there so that when we're getting into the crevices, we're kind of cleaning that stuff out. And then for the nozzles, we will remove the nozzles from the machine, and then we will stick this almost dental solvent thing into the nozzle and kind of flush it out with isopropyl alcohol or water, just kind of pressurize it there. So our cleaning bench. All of this happens at our dedicated cleaning bench. This is one we found from our link, which is set up to make the process seamlessly and easy to flow. As you can see here, we'll have our required materials on the bench. On the left, I kind of just showed where our gloves and extra stock will be held. And on the right is where the whole process will be happening with the alcohol wipes, the cotton balls, the cotton swabs, etc. So our expected results. With our process in place, we expect improvements across 3 key areas. Cleaning efficiency, with every part will be cleaned thoroughly for use. Operator efficiency, clear guided steps reduce operator frustration and minimize the time needed to perform the activities. And a clean machine performs better, so glue application will be more accurate and timely. So a sticky detail we we initially tested a solvent called methyl alpha ketone, also known as MEK, and were impressed with the results. It cleaned hardened glue incredibly well, but when we approached EHS, we hit a roadblock. The regulations around that solvent were stricter than we anticipated, needing a fume hood and a lot of safety regulations to be put in place in order to be used. So we kind of pivoted to using isopropyl alcohol and the isopropyl alcohol wipes. So after further testing, we actually found it to be effective enough while also meeting all the safety requirements as it's pre-approved by EHS already. It was a challenge, but it helped reinforce how important it is to align technical feasibility with environmental and health standards. Before we wrap up, we want to give a special thank you to John Bonzo, our guide, and Tiffany Geringer at L3 Harris for their ongoing support and guidance. They helped us to stay motivated and focused throughout the whole project. Thanks so much for watching our presentation. If you have any questions or want to learn more about our cleaning process, come visit us at Imagine RIT in Engineering Gleason Hall, table number 3. Thank you.